Hello guys, thank you for coming. Today we're going to be continue reading the paper GPT-3. The paper's title is Language Models Are Few-Shot Learners. Today we're going to be continuing from section 3.9 and we're going to be starting from the most important subsection, news article generation. You may have been played with this already, which is ChatGPT. So I won't explain the scenario right here. You know all this, right? But the authors do have played a experiment or human evaluation experiment in which they ask human being to see if they can tell the generated text from the human written text. So the task is a news article generation, and they use the news title as a prompt to get a response from the neural network model. And in table 3.11, you can see that they use a control model. It's a deliberately bad AI model which generates something. But you can see that with this model, human being can only do 86% in terms of the accuracy. So this caused me to ask this question: are these people are really doing their job with responsibility? Because to me, from my own experience, if given a very bad AI model generated text, I can probably do a 95% accuracy, but maybe they won't pay me well. So this is something that I question them. And you can see that when the model size went up, the mean accuracy dropped. Eventually, they get almost a 50%. What does the 50% mean? So if you do random guessing, 0, 1, 1, 0, 1, and if you sample those, or if the ratio of the generated text and the human being written text is 1 versus 1, okay, then I do random guessing, I will get 50% of accuracy, right? So this one is very close to the level of full people around, okay? But like I mentioned before, these people are not doing well on the control model, which is a very bad model. So I question whether this 52 is really 52 or something higher than this. And they have done t-test, and this is a p-value. You can do your own research about what is t-test and p-value. And they have also allowed the user to say, I don't know. So I think, if you pay these people, I think you can ask them to explain why do you think they do not know. Okay, ask them the reason. Okay, because if you give them the option like this, I think most of the people would more prefer to say I don't know. Okay, so this thing. And then if you look at table 3.12, in this time they increase the number of text generated about 500 words versus 200 words in the before. The mean accuracy is still 52%, but the controlled experiment, you can see that people can do better, more text, right? But the interesting thing is that the confidence interval became wider, and also I don't know assignment went larger. So that means people are more uncertain about the generated text, whether is written by human or not, because the interval went up and the I don't know assignment went up. So that means when there are more text being involved, people are likely to make more mistake in detecting these AI generated text, especially GPT-3 generated text. So because I've talked about this, let's see something interesting. I don't know whether you have heard of, I think it's one Ivy League undergrad, I think. He I think in his district, the high school teachers are troubled by essays submitted by their students. These essays are sometimes written by GPT-3 or ChatGPT. And it's unfair for people who do not use ChatGPT-3 because teachers like to be impressed by essays written by GPT-3. So those high school teachers ask this guy, can you charter a anti-GPT tool for them? So this guy come up with a GPT-0, and the goal was to trying to detect the AI generated text, especially the essays. But you have seen the experiment, okay? And this paper was published maybe like almost 2 years ago. Human beings will not be able to tell a good job in telling which is which. And this is 2 years from that GPT-3 paper published. And the GPT has been evolved to GPT 3.5. So I personally do not think the GPT-0 could finish this goal not because this guy is not smart, but philosophically speaking, I think you gotta have to have lots of text generated by GPT-3 and lots of human written text. And then you train a model on these things. And you have to see a lot of GPT-3 generated text, right? That means you probably have to have a very large model. I don't think this undergrad would have this amount of training power. But fortunately, I think I read some articles before. GPT-3 guys, they have mentioned this. They have noticed this issue. They are trying to do something. I think there are many ways of doing this, but this is not the key point of today's paper reading. I will go back to this, and then now we could quickly go over the section 3.91. 3.91 is arithmetic task. I think the goal of this subsection is not. I think they have said this. Perform simple arithmetic operations. Because if you think about this, generating text is more like grammar things, but you want to see if the model is capable of thinking logically. For example, you tell the model 1 plus 1 equals to 2, and then 1 plus 2 equals to 3. Can the model infer that 1 plus 3 equals to 4? Can they do it? Or if you tell them 2 plus 2 multiply 2 equals to 4, but what does the 2 multiply 3 equals to? Right? This type of I would say the word deduction. I sometimes mistake the word induction, deduction. I think this is deduction. Oh, you can call that induction. Induction is that you're given lots of examples. So what the next example could be. Deduction is more like given this certain type of rules, can you, based on these rules, guess what the result is? I think human beings are more like to. So when we learn math, we learn this deductive. When we learn in this deductive method. But I think for machine learning, they're more like learn this type of stuff in an inductive style. So it's given several samples. What's the next sample? Given several examples, what the next case should be. Okay, and then you can see they have done the 2Gs addition. It's a pretty much elementary school first grade, second grade stuff, right? These type of 3-digit subtraction and 1-digit composition, right? Read it yourself. I have to say the model did really bad, really bad. Except one thing, 2-digit addition when the model size it went up to 175 billion parameters. You see, this is almost 100%. I think most of the guys are like me. We're only content with the model if the model can do above 95% for this simple task. But indeed, most of them, they cannot. They can only do 2-digit addition and 2-digit subtraction above 95% on their largest model. So this actually may suggest the model is not capable of doing this type of logical thinking stuff as human being, at least as of now. And also the interesting thing is, if you look at the GPT model, okay, remember when you play with ChatGPT, even you send the same prompt to the API, the response might be different from time to time. That means there is a probabilistic factor in the model that controls the generated context so that every time it's different. So this thing is also effective in the arithmetic computation. The thing is, for their 1 + 1 = 2, so the 2 actually correspond to a probability of result equal to. So this does not equal to 1. So there might be very high, like a 0.00009. Sorry, 9999999. There might be something like a y = 3 equals to 0.00001. Because of what? This is my explanation. Because they learn from the text. Okay, tons of text they crawl from the web. It's likely some people saying that 1 + 1 could be equal to 3. So they learn something from this. Okay, so the probability of 1 + 1 = 2 does not equal to 1. And every time the probability is different. Word scrambling and the manipulation task. So frankly speaking, I didn't quite get why they're doing this experiment. They didn't say the goal right here. But the thing is strange to me because this is English. They train their GPT model leveraging something called word piece. Word piece. Which means the word, for example, computer might be composed of 3 word pieces. For example, maybe 2, okay. Computer. So you can see this is not trained on the letter level, but they're trying to do some letter manipulation. They're saying word scrambling, but it's not doing word scrambling, right? They're doing letter scrambling. And it's not doing well either, right? You see, even the largest model, the best that they can do is on the task of random insertion, but most of them are below the accuracy of 50%. So I will skip this. And they're doing the set analogy. A set analogy, I think, I haven't taken the set exam, but I did the GRE verbal test. So I'm familiar with this. So this is, for example, this task is analogy, right? Sorry, synonym, right? Synonym. Yeah. Synonym. Sanctimonious to hypocrisy is the same thing, is the same synonym. Audacious, it both is synonym. Okay. And GPT is not doing very well in this. Although they're saying that on average, the students are not doing very well on this. It's only 57%. I guess you took the international student into account, but I think American student could be doing better than this. They're saying they're achieving the performance of average student, but it's not very satisfactory, right? Okay, 3.94, we have covered this. So now I think we should move on to learning using novel words. I think this is interesting to me, although I'm not sure whether there's any NLP task in this, because this is important for an AI model to be learn something new as a elementary school student, because somehow you teach the student, for example, water pool is a small furry animal, and then to do a fur, and then you ask your student to give you an example of using the word water pool in a sentence. So this is what GPT-3 can do. They say they're traveling in Africa, and they have seen very cute this. I think the GPT-3 is doing a fairly interesting job because the word Tanzania is in Africa. So the GPT-3 generate the word Africa in the sentence with the word water pool. So it makes sense, right? And in this task, what's the performance? 3.95. They have not done any evaluation, even human evaluation on this. I think you could probably ask, you could have the AI generated sentence versus a human being generated sentence to see which one can be doing better, or you have the elementary school students results, the middle school student results, and even college student results, and to see which level your AI model is at. Okay, I personally thought this is like elementary school student level. Correct English grammar. This is advanced version, but they have not done any evaluation on this. And to evaluate whether the English grammar correcting is doing well, it's more difficult. You have to hire professional linguists to do this type of evaluation. Or sometimes you can fake some data set, I think. For instance, you can just grab president's speech, the transcripts of the president's speech, because for those speech, my understanding is that they're written by the best linguisticians that you can possibly find. They have a very, very delicate use of words in that speech, and that there's no grammar mistake. You can try to alter some words to see whether GPT-3 can find these words and rectify them into the original word that these human beings are using. And I'm personally very interested in the English grammar correction because I personally made a lot of English grammar in my oral English, in my written English as a second language learner. So I think it's very important because I think if you can do this well, you can just leverage lots of English teachers. You can just relieve the English teachers from the tedious essay reviewing work, because in that way the teachers do not have to spend time on those preposition errors. They can focusing on more on the structure of the essays of the students, give them more high level instructions to make the tutoring process to be more effective and efficient. Okay, I think we come up to section 4, which I think is very important. I do have some of my own thoughts on this, so please see what I say, okay? This is something, it's called measuring and the preventing memorization of benchmark. Let me first explain the scenario that they are in. First of all, where do they get their training data? They use the data of Common Crawl since maybe GPT-1, at least GPT-2, okay? Common Crawl is a data set. Somebody crawl the data from the internet web because the data has the Creative Commons license, so they can just freely crawl them, okay, without worrying too much about the copyright issue. But when you crawl this data from the internet, you're also facing a issue. Suppose you later on you want to do some lots of downstreaming tasks, for example, NER, QA, or reading comprehension. And most of the time, when people collect those data sets, especially the academia people, they decided that they should use some pre-existing data on the internet. For example, I think lots of the QA data sets are indeed derived from Wikipedia. And you see the problem, okay? Because the Common Crawl definitely crawled Wikipedia. So the issue became here, the training and the testing set, and also validation set, they have overlapping contents. Is it okay? Does it mean that the model will memorize the overlapped content and do a better job when facing the test set? So here is their study results. Let me just show you their conclusion. So they're saying that statistically or on average, having overlap in their model does not make their, on average, does not make the accuracy higher or lower. You can see that some are better, some are worse. Okay, when this is about green part, anything that above the on the upper part of the chart, it's better. So that means overlapping give them advantage. On the bottom is vice versa. But I would say, though, so they're saying that no, sorry. So if it is on the bottom side, that means overlapping give them advantage. Or this vice versa. You can see this is like evenly distribution from up and bottom. I do not want to analyze specific tasks as they do, but let me tell you, how do they clean up their training set? Okay. So for each benchmark, they produce a clean version which removes all the potential leaked examples, defined roughly as examples that have 13-gram overlap with anything in the pre-training set. So if there are two, so suppose there are two paragraphs in the training and testing set, okay, and it happens that in the training set there's an utterance which has 13 grams, or part of the sentence that has 13 words or word pieces. It is word pieces, the same as the word pieces sequence in the testing set, they would call this as an overlap, and they will remove that training text from the training set. Make sense? So let me quickly look at the appendix C. Okay. So they have dozens of experiments. Do they actually mean they have removed the overlapped section for each task? That means they have to retrain their model dozens of times, if you're with me, okay? Let me see their filtering process. You can see this. Documents split more than 10 pieces were considered contaminated and removed it entirely. Originally, we removed the entire document with a single collision, but over penalized a long document and a book for false positives. We ignored 13 grams, matched the 10 training documents. Doesn't answer my question, I think. Yeah, these are the details of each dataset which has the overlapping content. Okay. So you can see that for Quack, only 1% is clean. That means, I think it means it's completely overlapped or almost completely overlapped. And the Winograd is 100% clean. This means there's no overlap at all. Okay. Let's go back to the content. They're saying that, or their conclusion is that having the overlapping in the training test set does not give them advantage. Of course, this results is presented in their favorite ways, because I think other researchers may criticize their experiment, saying that, okay, you guys have crawled lots of data set from the web, and you claim that your model is doing better than some traditional task because you have overlapping. But they have done this type of experiment to show that in favor of their ways, by saying that, okay, you see, I did all of this, but for some experiment, I have some advantage, but for some experiment, I suffer from the overlapping. So I guess the true reason was because of this. So the GPT model is all about estimating the PY given Y history, right? Given a history or a sequence of words, what's the next word could be. So you can imagine that I can plot the distribution of the posterior probability, or the conditional probability, P in a, suppose it's suppose I think I should let's say Y only has two values. This is a very simple case, okay? Only two classes. So then I can plot Y, which has Y1 and Y2, okay? Each Y equals to Y1 and Y2. So I can say this posterior probability resides in this region, okay? This is the center of it. And then suppose you have suppose this is a clean you train on a clean data set, which does not overlapping with anything, okay? But then suppose you're doing a QA task. Let me use the blue color for QA. And then you have some distribution of the PQA Y given Y history, right? Then this one probably resides here. I mean, only the QA part of training set resides here, okay? And then you just merge these two data sets together. I mean, the original clean data set and the QA data set. So what do you think the updated probability of a general GPT model would be? It's easy to understand, right? The model would probably, I don't have a third. You can definitely imagine this new model would probably be sitting on here. Are you with me? Yeah. So, and then, so you can definitely see that once you have the overlapping with just one data set, your model will definitely get advantage, no doubt, because in the speech recognition, we have played with this. If your training set has seen the text set, or the validation set is very close to the test set, you're gonna get a big advantage when you tune your model on the validation set or train on the overlapped training testing set. Big advantage. Your WR could drop at least 50% relatively. And then, but you may ask why this GPT model wouldn't get too much from this, or the error rate didn't drop that much. So here is my thought. Let's say they have another task. It's called reading comprehension. So they have the reading comprehensions, conditional probability. Let's say it's located here. And then in this time, you do not, the read comprehension, when you merge the read comprehensions data set with the clean data set, you also merge that with the original QA data set we talked about. So this time, three data sets are merged together. This is QA, this is the RC, this is the probably common crawl data set, the larger data set, okay. And then where your final model's probability distribution would be sitting on. But this time, let me use the light blue color to represent this. It's very likely to be sitting on this, because these two models, if they are not sitting at the same position on the hyperplane, they may cancel out the effect caused by each other, right? Like the more tasks you added, the more tasks you added, the more balanced or the more canceling effect of each data set you would be observing from this, okay? And you can see that eventually, I think the super large models distribution would be still not very different from the original clean dataset trained probability distribution. Are you with me? So that explains the model does not change very much for lots of the models. Okay, that's my explanation. But so this comes to the next question. Is it okay to have overlapping between the training and the testing set? I think even the author, they do not want this, although they're saying that this is not giving them advantage, because they have definitely mentioned that here. Look at this. They have made a best effort to measure and document the effect of the data contamination. That means they wanted to reduce the effect as small as possible. And because of why? Because they want to study their model better. And you can see that when you have this overlap between your training and testing set or validation and test set, that means you're not training a model that can be generalized. You're more likely to overfit your data on some known cases. So that hinders the model's capability of being generalized. Okay. Let's move on to section 5, limitation. I think most of this limitations they talked about is kind of outdated because this is almost 2 years ago. And they do not have lots of quantitative analysis, so I would just skip them. I think I may have forgot to explain this training curve. It's doesn't have lots of information in it, in my opinion, because this is known to all of us. You can see that this is the model size from small to large. Large is small, maybe this is medium. You can see that if the model is small, the cross entropy loss is still very high. But if you increase the model size, you can get a lower loss. Means the models is trained can model your data better. And you can see that validation loss is always above the training set. Okay, there's also always a gap. Remember, validation loss should be higher than training loss. This is the machine learning 101 or deep learning 101. But they're saying that the gap is not caused by overfitting. It's more like a training difficulty. That's known to all of us. What does the section 5 say? I don't think it has much to say. Broader impact. Broader impact does not have quantitative analysis also, but it does have some interesting examples. I think this is the entertaining part. If you're a tech savvy guy, you can turn off the video now and don't forget to hit subscribe. For the entertaining part, I think I'm really entertained by those results. It's interesting. It's better gender one. Look at the case here. They study the generated text. One thing is, suppose you're given you have the word competent in a sentence. What the occupation are usually be, okay? Definitely you can see that. Whether this is a female occupation or it's a female related occupation or male related competition or occupation. They also use the word incompetent, okay? And they use this equation. This is average sum of all the jobs, and this is given the context, the probability of the female and probability of male. Female is on the top, male is on the bottom. So say this is a probability of a female is smaller than the male. So this is less than 1. The log will be less than 0. So that means they will get a negative value. Okay, remember that when the female probability is less than male, you will get a negative value. And you see for the all neutral, competent, and incompetent variant cases, female's probability is all smaller than the male. What does that mean? You can pause the video and think about yourself. Okay, it means that women are more likely to be neglected, in my opinion. Doesn't mean that women are ineligible, but the model, the AI model, is more like less likely to comment on the competence of a female than male. It's more likely to say either the male is competent or not incompetent, other than commenting the competence of female. I mean, even for the neutral variant, the model doesn't want to comment. You see, even for the neutral variant, if the probability of female is also less than male. Okay, because it's not about a bias this time. It's like a less represented. Okay, because if you comment the occupation is something like a neutral competence, doesn't mean that you're suppressing certain gender, right? But even though the model doesn't want to comment on females, neutral variant words. See this? Interesting, right? This one I think it's we know gender dataset, so you can perform some gender study. So the interesting thing is that so if the question is about or the answer, interesting. So the correct answer was occupation option for females or higher than for males. Better than on the female cases. Yeah, but they also didn't explain why. There's some interesting. What they say that interesting facts or results to be shown to all of us. And these are most biased descriptive words in the largest GPT-3 model. These are very interesting. I won't read this. You just check it by yourself. This is male biased male descriptive words. This is biased female descriptive words. And they say more often describe the using appearance-oriented words. And these are men who are often described using adjective that span a greater spectrum. Adjective. Okay. Race. Yeah, the race, the Asian had a constant high sentiment. Black had a constantly lower sentiment. How about when the model size is different, this thing got changed? Interesting. And these are the religion words, most favorite descriptive words for each religion. Atheism, interesting. Religion. Energy usage. This is not about training. This is more about inference time. Related work. I really want to read this paper, but today we're out of time. So I guess I would just stop here. But before I stop, I want to read the conclusion because reading conclusions is very important. I think they missed the S here. They presented 175 billion parameter language model. Just remember 175B, which shows strong performance on many NLP tasks, and the benchmarks in the 0-shot, 1-shot, and few-shot settings. I mean, the 0-shot is most important because that means the model can perform can be generalized, or say that it can be something close to artificial general intelligence, AGI. In some cases, nearly matching the performance of the state-of-art fine-tuned system. That means it's slightly worse than the sawdust system, right? As well as generating high-quality samples and the strong quantitative performance at tasks defined on the fly. These are kind of subjective to me. And this is subjective evaluation. Lots of human beings are saying that they cannot tell the generated text versus the human written text. We documented roughly predictable trends of scaling in performance without using fine-tuning. That is true. 0-shot or few-shot learning doesn't involve fine-tuning. We also discussed the social impacts of this class of model. I think they have done, they probably should add an appendix or write another report, because I think most of the guys in this paper are technical guys. They're not a social, what do you call that? Social science researchers. Despite many limitations and weaknesses, you're right, there are weaknesses and limitations. These results suggest that very large language models may be an important ingredient in the development of adaptable general language system. Very general. Thanks for watching. What do you think? If you want to comment or point out the mistake I made, please comment in the comment section. If you like this video, please hit subscribe or share that with your friends. Goodbye.